this button. And it is just the lecture today. So let's go and do it. One more lecture on classes before we start a new topic. So let's finish them up. Have some fun. Alright. So let us finally do that example that I did at the very start of the semester when I showed you classes, but you didn't know that. I was like, I'm going to make a type. Remember that? We can recreate it now. So let's do that. Let's recreate our counter library that we made using just functions, using real classes, so we can have multiple counters, they can all count up. It's going to be great. And so here are the operations that we would want to do on a counter object that we're going to make. So we want to be able to initialize it. So like you make a counter, make your own type, counter, call it C, and then you have to remember to initialize it, c.init. Let's see, c.init, parenthesis, parenthesis, and then we can start like incrementing that counter, right? c.inc. And so a lot of things, some information is going to live inside of every counter object. So like here's C, what should it have as a member variable? It should totally keep track of the count that's inside of it. So we should keep that. Hold on to that. And then we want to have all those operations. And you think of them as being part of the objects. Like it knows how to initialize itself. C knows how to increment itself. It knows how to decrement itself. And so when we call c.init, that will set C's count to 0. Silly zoom window. And then if you call c.inc, oops, I forgot some parentheses there. If you call c.inc the method, it will go and ask the counter to increment its count member variable. So that's our plan, all right? And so here are the operations that we'd want. Obviously, we're going to make our member variable that is storing our count private. So if the user wants to get the current count, they're going to need to go through a getter. All right. So I think that's what I want. So yeah, let me draw this one last time. So the first line, counter C, just makes the counter object, but the count is garbage. We don't know what it is. Then c.init will set it to 0, and c.inc will set it to 1. There. All right, that is now accurate. So let's make the class. Let's do this. Counter.cpp. So what do I want? I'd like to make a brand new class called counter. And what do I want to have live inside of every counter object? I would like a private count member variable. And it's just going to be a number, whole number, so int count. That'll be fine. And then let's have these methods. All those guys. See if I can copy them. So this is what I want to do to a counter. All right, I want to be able to initialize it. I want to be able to give it a new count, reset it to some new count. I want to be able to increment it, decrement it, and give the count back. All right. So these all need semicolons. And what types are these going to give back? So init is just a void method. It just does something, messes with the class. Void, reset as well, I think. That would work. Just change the value of our counter's count to some value that we give, that we pass along. Inc and dec, also void methods. They just go off and they're meant to be called on a line by themselves, right? They just go and change the value of the member variable. And then get count, well, what should that do? I guess that goes and gives back our current count, so that actually needs to give back something other than void, right? So that's going to finally return something. And this one should be a const method. All these guys are going to change the count. Get count should just give it back. All right? Any questions about that setup so far? Not horrible, I hope. All right. So let's make a little main function. Let's try and use our counter, and then we'll see what we can do with it. So let's make a counter C, and then we always have to remember to initialize it, c.init. It's kind of unfortunate, but that's fine. And then let's increment it 3 times, c.inc. ink, ink, ink. And so now, like this is like a little mini test for us, right? If I print out c.getCount, it should give back 3. It's a very complicated program that prints 3. And then we also have the, let's see if I can split screen this. Here are our operations over there on the right. What else can I do to a counter? I can decrement it. Dec. Now the count should be down to 1 again, yeah? And then I would like to be able to reset my counter's count to some arbitrary value, so that's what the reset method is for. So like c.reset, reset the count to 42 or something, and then increment it and get the count. Now it should be holding 43 when we print it, yeah? That's kind of how I want it all to work, and those are examples of all of the methods. So does that make sense so far? Are we ready to implement it? All right, so let's make it happen. Let's get all these guys out here and let's start implementing them. What do we want to do? Oops, I went the wrong way. So this is counters a init method. It's not an init function. These are methods. Counters get count, and then we need to give them bodies. Let me fill them all in with blank things right now. Slowly but surely. All right, now what do these all need to do? So you have a counter, you need to initialize it, which means set the count to 0. That's a good starting value for a counter, yeah? So set our count member variable to 0. Cool. And then reset is very similar to init. It's just like take your count and put whatever new count is inside of that. Perfect. And then inc and dec, those take your count member variables and either add 1 or subtract 1. Count plus plus versus count minus minus. And then get count is going to return init. It's going to be the way that the user accesses the counter's count. So return whatever our count member variable is holding. Okay, so those are all the implementations, and here I am using them over here. And let's see if it works. Can't show you everything, but that's good enough, I hope. Let's compile and run. Yay, and so I do get my 3, and then the 2 decs bring it down to 2, or sorry, down to 1, and then reset to 42, inc to 43, print 43. All right, so it's all seemingly working together. Are there any questions about that? And the beauty of having classes is like when we were doing this with just functions, we only had one counter, just the counter that we could init and inc and dec just once. I can make as many counters as I want right now. I can make counter D, counter E, counter F, as many as I want. And they all have their own counts. I can increment them and initialize them all. It's glorious, right? So that's the beauty of classes. Hopefully that makes sense. We good with this so far? That's kind of what I did very, very early in the class. I showed you that. Now you know how to do it yourself. So let me tell you a secret now. So when you call a method, I know I taught you to think of it this way. Think of every method as like belonging to that object, like because it knows how to work on that particular object. But secretly, where am I trying to go? But secretly, every method is just a function at the end of the day. It's secretly just a regular function, but it gets a secret parameter. We give it a secret argument, all right? It's the object itself. So when you say c.inc, secretly what the compiler is doing is it's translating this into a call that looks like this. It's going to call counter : inc like a function, and even though you didn't put any arguments here, it's going to give the thing itself. It's going to give c as a secret argument. All right? That's the secret 0th parameter that goes before everything else. And this parameter is called this. You might be reading about that in your book right now, or maybe a little bit later. There is a secret thing that you can use. There's always a variable defined inside of every method called this that is yourself. You can always access yourself through this thing called this. We'll get into that in the next set of slides. But yeah, that's the beauty of it. So secretly, there's more to this, but this is what I want you to know right now. Here's what's going on. If you're like in main and you make a counter object and you call inc, like here's C, it has a count of 0 and we call inc on it for the very first time, here's what happens. we make this call. It's really just a function call. It's a call to counter ::inc, and it's going to pass along a variable. It's got a secret variable called this inside of it. Oh no, I don't want to make it bigger. Just want to move it. There we go. On this. Okay, that's the beauty of it. That's how that works. And this is a way of getting at, it's like a reference in a sense, to this object. Alright? And so that's how it knows which object you're calling inc on, rather than like c.inc versus d.inc, for example. It knows the difference because it's passing along the object it wants you to work on right then and there. Alright, so this is your secret 0th parameter, comes before everything else when you're calling methods. And so that means, that's why actually C++ is happy when you say stuff like count plus plus, count equals 0. It knows what count means because it's secretly getting the object you want the count messed with, like as part of the call. So like every time you say count plus plus, let's see if I can make the T and the plus look different, count plus plus, when you do that, that's being translated into this dot count plus plus, secretly behind the hood, right, under the hood, plus plus. That's what's going on. You don't have to understand that fully right now. This is just, it's saving us a lot of space, because you could imagine it would take up a lot of memory to like save multiple different kinds of the same method. No, we're just making one, and it's really just a function, but it's getting the object that we want to mess with as a secret parameter, as a secret argument. Okay? Any questions about that? That's just one of those weird things that will make a lot more sense later, but I wanted you to hear about it once before then. Alright, so now we're ready for some cool ideas that will make sense. So this init method sucks. It's unfortunate, right? We have to remember, if we ever want to do anything else, right, after we make a counter, we better call init on it, because if we don't, right, if we forget, it will be set to question mark, the count, and we have no clue what inc is going to inc at that point, what dec is going to dec. So you're kind of forced to. You have to always remember to call c.init right after you make the counter c. You have to do that for every counter. That's kind of disgusting, right? That leaves room for many errors to happen. Does that make sense? We don't like that. There's got to be a better way, and there is. It's called a constructor. Okay? So here's the idea. So like if you forget to call init on a counter, you get garbage. C++ has a way of allowing us to never forget to initialize our objects. It's called using a constructor, right? A constructor is a special kind of method that is always called for you one way or another. Some constructor gets called always whenever you make an object, right? And so it's just a method, but it has a secret name, it has a special name. So the name of your constructor is always the same as the name of the class. So if you're making the class counter, your constructors, you can have multiple, and pick which one you want called. Your constructor is the same name as you. And there is no return type as well, because it's like, it's making a counter. You just write counter twice, maybe. But it has no return type either, because it's like, you're making the thing. There's nothing to return. You're returning yourself. It's implicit. So the name of the special method is the same as the name of the class. So for counter, your constructor's name is counter. For point, your constructor's name would be point. Whatever you're making, same name. And you don't put a return type, since part of the name itself, you're making a counter anyway. Just write it once. And you can have as many constructors as you want. They can take multiple parameters, and I'll show you how to give parameters. But there is a concept of this thing called a default constructor. A constructor that takes no parameters, no arguments, is called a default constructor, and that's usually the one that you use. Okay, so let's make some constructors for our counters. Let's make a default constructor and a one parameter one too, one that takes a parameter, right? And this, I'll get it so that we never have to use init again. Isn't this beautiful? So the second I make a constructor, init is no longer necessary. Beautiful. And then that means we don't have to do this. going to be done for us. All right. So here is the idea. Here are our constructors. Let's make 2 constructors. Let's declare them. First, let's get just one window. So constructors. Let's make a default one. So that's going to be the name of our class is the name of the constructor. It's always like that. And a default constructor takes no arguments, has no parameters. So this is your default constructor. It will run it. Will like initialize the count to 0, let's say. And then we'll make a constructor that takes a parameter. Parameterized constructor. And an obvious thing to want to give to a constructor is like, what do you want the, not string, starting count? What do you want the count to start at? Do you want it to be 0? Call the default one. Do you want it to be something else? Call this one. You're forced to call one or the other though, so which is great. And so I can comment out this init method and we can start implementing constructors. Okay? So let's initialize stuff inside of these constructors. Let me show you how to implement these guys. So they look a little weird, but here's how they work. So here is the default one. It's just a method, just has a weird name and no return type. So it is, if you're going to implement it outside, it's counters counter method, right? It's a constructor though, because it has the same name as the class. No return type. Counters counter method with a parameter this time. No return type. Okay, so that's your default constructor. That's your parameterized constructor. And here's what we want to do in each of them. So for the default constructor, by default, what do we want to do to our counter? How do we want to initialize it? We can set our count to 0. Okay? And we'll just print out, cout, I'm in the default constructor just for fun. So we watch it happen. I'll show you when it happens in just a second. And then for the other one, for the parameterized constructor, let's print out that we're there. I'm in the parameterized constructor. And then we'll set the count to whatever the user gave us, the starting count. All right? So the user now, by having constructors, the user is forced to call one or the other. It is always going to happen. You cannot mess it up, which is great. And it's going to make our count have a normal value. Isn't that nice? So here's how you use these constructors. So here they are defined up here. We actually already used it. This line right here, where you make a counter, this line calls the default constructor if you have one. This line calls the default constructor. So we don't need an init anymore. As long as you implement a constructor, just this line, by default, it's calling the default constructor because you're not giving anything extra. You're just saying, I want a counter, please. No arguments anywhere, right? So that's going to hit the default constructor, set the count to 0, and everything else is going to work as before. Isn't that gorgeous? You can't forget. Just by declaring it, it all works out. And so at the very start, it's like, I'm in the default constructor. It's getting called on this line. Set the count to 0, and everything else works out exactly the same as before. Any questions about that? So that's just this line, declaring it. If you have a constructor made, oops, up here and defined and initialized and given a body, it will work. Am I good with that one? You're probably wondering, all right, if this is the kind of line that like calls a constructor, how in the world do I give an argument? How do I give this one? How do I make this one happen? Let me show you. Let's make a new counter. Let's put a little separator here. Let's make another counter. Counter, I don't know, D. So if I put the semicolon here, that's calling the default constructor and setting the count to 0. If I want the count to be something else, like 42 or 33, I can start putting parentheses and arguments right here after the name. It's a little weird to be doing it like this. It doesn't look normal to us yet, but this is how you do it. This calls the parameterized constructor. And so it jumps up to the parameterized constructor body, and it gives it that starting count. And it's going to set the count to that. So the count will start out at 33 now, and then we can like use it as normal, increment it. Now it's 34. Cout D. This is a new object. D.getCount. That'll give back 34. Huh. Any questions about that? So that's how you call a parameterized constructor. Just this line, one way or another, the line that you make your object on is going to call one constructor or the other, depending on if you give arguments or not. and then you can use it. It's initialized, it all works out, it's happy. That's our parameterized constructor. And this was its declaration, and this was its implementation. It gives it a starting count. All right. Any questions about that? Is that making some sense? It's great. Constructors are wonderful because they make it so that we can't forget things. All right. So you can make as many constructors as you want. You can initialize things in many different ways, as you know. Okay. So if we're happy there's a cooler way to do it. Inside of a constructor, you get access to something called an initializer list. And that is kind of the way that I want you to be initializing things because it works for everything. So if you want to maybe construct a member variable, like say you're forced to use this thing called an initializer list if you want to do this. So like let's say I include the vector library. What if for some weird reason, every counter gets a vector? Vector of ints, call it v. For some reason, I don't know why. But for fun, let's pretend it does. Vectors, do you know that those have different constructors? Like this is, if you declare a vector like this, it starts out empty. But vectors, just in general, there are different ways to make them. I showed you a fill constructor, I think. You didn't know that was its name, though. Like a vector, you can initialize it in many different ways. Here's its constructor. Now you know that word. There's multiple different ways to initialize a vector. One way is like you call it with some things like I want to make 4 ints having the value 100 if I call the vectors constructor like this. So you might want to, inside of your class's constructor for counters, you might want to construct v in a special way, call one of its other non-default constructors. You are forced to use this thing called an initializer list if you want to do that. And also, if you want to initialize a const member variable, one that can't change, the only place that you can set it once and for all, and then it never changes again, is in this place called the initializer list. So this is worth learning about. All right. So the way that you use an initializer list is in the implementation of your constructor. So it's like class name, colon, class name, and maybe you have some arguments. The place that you put this thing called the initializer list is after the parameters, but before the body, in between, okay? You put a little colon, there, and then you comma separate a bunch of constructor calls. And then you give the body. It's going to look a little weird the first time, but that's the secret. That's how it works. So this is how you notice the initializer list. It's a little sad face. So look for the sad face. Remember the sad face. That's how you do it. Look for the sad face. There it is. Whee. And then constructor calls look like this. This is a member variable. X1 and X2 are member variables. And then you call their constructors just by saying their name and giving them potentially parameters like we did here. Okay? So this will make sense with an example, I promise. But that's the setup. And this works for ints too. Like we could use an initializer list to set our count member variable because this is a thing. Instead of saying int x equals 42, every type, even primitive types like ints, have constructor style initialization possible. So instead of this line, there's an equivalent line that looks like this. Int x, call it like a function, 42. Initialize x to 42. It's like its constructor. So these two lines both make a new variable x and set it to 42. Okay? So I can use this style syntax in an initializer list to set like an int. That is how you do it. So let me show this to you. And please shout at me if you have any questions. It's a little weird, I know. So, for example, if I want to do this one, like I'm in the default constructor, I want to set the count to 0, I don't have to do it in the body. I can do it in the initializer list. Here. Colon, count 0. That's how you can use the initializer list to set a member variable's value. Use this constructor style initialization. You can call constructors on your member variables. And so I'll do that with v in a second. But same for this parameterized constructor. How do I want to set the count? I can do it in the body or I can do it in the initializer list. I can say the name of my member variable and I give in parentheses the value that I want it to be. That's like the ints constructor. Give it the starting count. And so now nothing has changed. recompile, rerun, same feature. It's just setting member variables in a different way using this thing called the initializer list. We're getting the same output. Any questions about this so far? So instead of this line, I can put it up here and it looks like this now. Instead of this line, I can put it up here and it looks like this now. Okay? And so this is the way, if you have a member variable and you want to construct it in a non-default way, then you use an initializer list. All right? So like, by the second you hit the body, if you don't mention v, and v is a vector that's part of your object, it has been default constructed unless you say something. Right? Unless you say something in the initializer list. So if you want it to not be empty, you can pass along, hey, v, make 100 values all holding 42. And so now that's going to call these the vector constructor, the fill constructor. That makes it so that now your vector has been initialized to hold 142s. Because that's one thing you can do with a vector. Okay, does that make enough sense? That's something you can do only in the initializer list. The other thing you can only do in the initializer list is set a const member variable. So like if you had a const member variable like called d, the only place you could set it is in the initializer list. It's too late to do it down here. It's read only by this time. Okay, so that won't work. The only time you can do it, the only place you can do it is in the initializer list. So that's why you're forced to learn about it right now. You have to give a little constructor call, and this sets d to be 3.14 right there, and it works out. Okay. And you're actually forced to do it everywhere. This won't even compile right now if I don't set it everywhere, I don't think. It's like, you forgot to set this in every constructor. You did it here, but you didn't do it here, so you better do it now. That's the only place you can set a const member variable as well. Okay? Does that make enough sense? I assume it's very fuzzy in your brain right now. It's a little weird, but with examples, I think it'll cause it to make sense. But this is a way to construct your member variables and set them and initialize constants. Am I good with that? Interesting little topic, but it's all about this little sad face right here. All right, so let's make this a normal counter again. Let's get rid of v and d. So we don't need any of this anymore. Boop. And then we'll get rid of this one. I'll just delete it. So that's another way to initialize stuff. Yeah. So with that in mind, I have a question for you. Let's see. Let me give you this. Come on, computer, you can do it. It's trying so hard. There we go. Here's the syntax. Member variable, parentheses, you give the thing that you want it to make happen. Here's the syntax to make a constructor. But let's pretend we have a point class again. And I'd like you to create a constructor for points. You can just write it on a piece of paper, work in a group and do it. But here's the setup. Say we have a class point, and it has some public stuff, one of which is going to be the constructor. You're going to put that there. And then inside of every point, right, you have x and y member variables that hold your coordinates. Please make a constructor that uses initializer lists for points so that you can declare and initialize a point just like this. Say point P, 3.1, 3.5, 4.7, it will create the P object and set immediately, using initializer lists, the x and y fields to 3.5 and 4.7, right? Any questions about the question? So you're going to fill in a constructor and also give an implementation maybe outside the class, all right? Please help each other. You can write this on the server if you want. You don't have to submit it, but I want you to try it, okay? Questions about the question? All right, give that a try. And you let me if you have questions. call to set your member variables using the set base, using that initializer list. Many steps. So this is definitely a parameterized constructor, right? Another minute or so, and then I'll show you my answer. Right, that is my timer. Let's see, here's how I would do it. I'll use green for the part that you would fill in. So this is the point class, and I'm making a constructor on points. So its name, when I declare it, is just called point. And if I want to pass along values, it must be a parameterized constructor, so it's got to take arguments. And I will have them be filled in into two separate ones, one for the x, one for the y. Double, like, I don't know, here's your x val. Double y val. You could call these parameters x and y, and then you're also forced to use the initializer list, because then these shadow the names of your member variables everywhere unless you use the initializer list, because the first thing is always your member variable, which is kind of funny. So there's that. And then how do we implement this? We got to give a body. Let's do it outside the class. So we got to say point, colon, colon, point. Point, colon, colon, point. Point class is point method. Two arguments, two parameters, double x val, and then double y val. Y val. And then colon, right? Sad face. And then you start giving the names of your member variables, x, And then inside of parentheses, you give what you want to set x as. So I want to set x to xval, whatever was passed to me, comma, I want to set the y member variable to whatever yval was. Does that make sense?
Mm-hmm.
That's how you do it. And actually now, since you're doing it this way, there is no need for anything in the body. You still have to give curly braces, but you can give them right next to each other. Empty body. There's no need to do anything. You've already initialized stuff using the initializer list. So that would be my answer. Does that make enough sense? Any questions about that? It is weird syntax, I know. But if you see it enough, it'll start making sense. We good for a new topic? Let's see. I think that will work. I want to teach you about that colon operator. It has a lot to do with classes. We've also used it in some weird ways already, like the standard library. It's always standard colon something, unless you say using namespace, blah, blah, blah. So let me teach you about that word, right? What is a namespace? Using namespace standard. What does that mean? And what does that colon really do for us, right? So every time you make a class, you've noticed that you've been using colon. Every class gets its own thing called a namespace, which is just like a place where you can put stuff, all right? So like a counter has a namespace so that you can make reset methods and inc methods and things like that live inside of that class and exist anywhere else. So think of the namespace as like another cloud. It's like what can you do? Inside of the counter namespace, I have inc and count and get count and all that fun stuff. Those all exist. The whole point of a namespace is so that you can have another thing called inc somewhere else and another thing called count somewhere else. A namespace is when you have two things with the same name and you don't want them to clash, right? So the whole point of having counters get their own little namespace is so that you can make a counter2 class. Counter2, make it a better way, and give that an inc method. Give that a count member variable. And these will never like clash with each other because it's counter colon inc and counter2 colon inc. They're different things, okay? I don't know if that makes at least a little bit of sense. So the whole point of this thing called a namespace, you get it implicitly with classes, is that you can have two things with the same name and the compiler will not complain because they are separate, all right? So let me give you an example of making just a namespace. You can do that in C++. That's what the standard library, everything is wrapped around this std namespace. And so let me make two functions and two global variables with the exact same name and show you what's going on. It's kind of weird. So let's make a new file called namespaces.cpp. And this is what happens when you say using namespace standard. You're just like, somebody's made a namespace called standard, and you want to import all of that so that you don't have to use colon anywhere. So here is the idea. I'm going to make a blah function. Blah, and it returns 42. I'm going to make another blah function, and it's going to return, I don't know, 13, Taylor Swift's favorite number. If I have both of these, I will not get this to compile, right? See out blah? It thinks I'm crazy. G++ namespaces.cpp-o namespaces. And it's like, what happened? Redefinition of int blah. They're both right here. Which one? I have no clue which one you wanted. I can't read your mind, dude. So you can have multiple blah functions as long as they are separated in a different namespace. So let's make a namespace. You can make your own just explicitly by saying namespace and then giving a name. Like here's namespace n1 and then putting some parentheses. Sorry, some curly braces. Then you put everything that you want to have live inside of the n1 namespace. There. And then I'll make namespace n2. And I'll put everything that I want to have live inside the n2 namespace. So now I've made two separate blahs. They have the same name, but they live in different namespaces now. And now I have another problem down here, but it's a different one. I am not being specific enough. Now I can get at both of these blahs by specifying which one. I want N1's blah function, please. I want N2's blah function, please. If they're in separate namespaces, there's no problem for them having the same name. Does that make sense? That's beautiful. And so that's the whole point of a namespace. So somebody in the standard library, somebody said namespace standard, and then they started defining a bunch of classes and functions. That's what we've been using this whole time. And if you don't want to use the : you can say using that thing. I'm using namespace standard, using namespace N1, something like that. All right, so you can get at both of these now like this. Now it will compile. It's happy. It knows exactly what you're talking about, and it will run. Are there any questions about that? So that's a way to have two things with the same name in different places. That's what it means to have a namespace. You're making your own cloud, different stuff. I guess I also promised to make you two global variables called x. So again, I can't make two x's out here. Can't be like int x equals 55, int x equals 33. Again, I would get a complaint from the compiler. But I can put in n1 in x, and I can put in n2 another x, and it's happy now. Totally fine. So I can just as easily be like, hey, n1, what is your x? Tell me about it. Hey, n2, what is your x? Print that out for me, please. All right? As long as they're separated, it's fine. It's happy. They're in separate namespaces. They do not clash. All right? And so we get exactly what we wanted, and it should hopefully make enough sense. Are there any questions about that? Not too horrible. It's kind of cool. It's a way to have multiple things with the same name and just have this like qualification. I want N1's blah, N2's blah, N1's x, N2's x. That's pretty nice. So implicitly, the reason I'm talking about this right now, implicitly, when you make a class, it makes its own little namespace for you with the name of the class, right? So that's why when you go and you implement things, you have to say, I want counters inc. I'm implementing that right now. Because you're talking about it outside of the class, it needs to know you need to be specific. Go through the namespace that's being created for you, right? So that is what I was trying to say there. And so technically, if for some reason you had a grudge against classes, but you still wanted the effect of classes, you could recreate your own version of classes by using just some functions inside of namespaces and structs. Because then you could like section off, okay, these are the methods, they belong to this namespace, and I can explicitly create it if you really wanted to. I'm actually going to force you to do that in a lab, so get ready for that. But that is, that's namespaces in a nutshell. And this : by the way, I think I forgot to say this. It's the technical term for the : is called the scope resolution operator. So technically a namespace also creates a scope. And you can go inside of that scope with the : like I want N1 scopes blah. But I also just say namespace. N1 namespace is blah, please. Okay. Does that make enough sense? Any questions about that before I switch gears back to the counter class? All right. So yeah, the last main topic of the day, last actual topic of the day, is operators. Operator overloading. So C++ is great because it lets you redefine what plus means for your own class. Redefine what times means for your own class. Java, other languages, some languages are sad and they don't let you do that. C++ is great because it lets us do this. So, for example, let's say I have two counters, C1 and C2. I cannot immediately, because I didn't give a definition for it, I can't go in main and say, hey, I want to sum those counters up, please. Let's use the plus. So let me section this off again. Here's a new idea. Wouldn't it be nice if I could do something like this? Counter sum equals C plus D. I made two counters. Like here's C up here. Here's D. We could add counters by adding their counts. Like, wouldn't it be cool if this existed? Right now, though, it won't compile because C++ is like, I know how to add ints and doubles. I have no clue what it means to add this thing of your type that you just made. It's going to give you a very long error message saying that. And that's okay because we can make our own version. We can tell C++ what it means to add two counters. Won't that be fun? So here's the secret. If you have objects, instead of like saying something like C1, you could also do this. You could make an add method, C1.add that into C2. That would work. But no, we want to use plus. We just want to say C1 plus C2. And so here's the secret. When you say the syntax, and C1 and C2 are objects of a class that you made, then C++ goes and looks. It's going to go looking for either a method called operator plus or a function called operator plus. All right? So if it sees C1 plus C2 and they're both counters, it's going to try to do this. It's going to try and make this code happen. Can I do C1 dot operator plus C2? Like, that's a method. It'll either try to do a method call or a function call. It's called operator plus C1 and C2. So it'll try and transform your call to either of those. It'll pick whichever one exists, so you only have to give one. And so that's the secret. Plus is secretly called operator plus under the hood. And so if you want C++ to understand what it means to add two counters, you implement the operator plus either as a method inside of the class that takes a single thing, the other thing that you want to add to, or as a function outside of the class that takes both things that you want to add up, and it gives back the new thing. Okay? So that's the secret. That's what we want to do. And so if we have our counter C that holds a count, I don't know, 3, and we have our counter D that also holds a count, let's say 4, then here's what I'd like to have happen. Counter sum equals C plus D. Here's how I want to implement adding counters. It gives back a new count, and it'll set it into the sum variable, and the count will be just the sum of C and D's count. And so it's 3 plus 4, so 7. That's what I want to do. So to add two counters, here's how I'll define it. I'll have it mean just add up the counts of those individual counters, make a new counter with the summed count. Right? It's a silly little idea, but that's going to show us this concept called operator overloading. All right? So, again, when I say this line, C++ tries to call either C.operator plus with D or operator plus as a function on C and D. So that's what's going to happen. Oops, I cannot spell operator. There. And we just need to provide one of those. All right? So let's go and implement one of those. Let's do it inside the class. Let's make it the method. Let's do it this way. C.operator plus D. Let's have that one work. So let's make an operator plus method because it's going to take our object implicitly. Here's how it will work. Dun, dun. So it's operator plus is its name. It's going to take ourselves because it's a method, and then it'll take the other counter. So counter other. And since we're just going to get its count, we can make it a const reference so that we save memory and don't touch it. That's nice. And then what should operator plus give back? It should give back a brand new counter that's the sum of ourselves and the other guy. And so this will let the plus operator work. It's great. But let me implement this outside the class. Sorry, getting ahead of myself. Let's just declare it here. Oops. So declare. And also, this operator plus is supposed to add our current count, our own count, in with the other's count and make a new counter. This is a const method, isn't it? It's not touching our own count. It's making a new counter with a brand new count. That's fine. This is a const method. So let's implement that. Maybe way down here. Boop. So this is returning a counter, and it's counters operator plus method. So it takes ourselves and takes somebody else, and we're supposed to add them up. That's the job of it right now. So we're going to make a new counter, call it result. And I could totally use its constructor if I wanted to, but I'm just going to set its member variable manually because we're inside the class right now. So what should the count for the result object be? It should be our own count plus the other guy's count. That's like I'm C and other is D right now. So count plus other.count. And so that'll make a brand new count inside this result counter that holds what I want. All right? So I save this. And then I come back down here. Let's, can I split screen this way? Yeah, this will work. And then I'll see out, so there's the implementation. See out sum.getCount, because it is a counter after all. I can get its count as usual. Compile and run. So we're also default constructing that result counter. But there it is. It's adding up the counter's count. So I think it's 43 and 34. So that makes 77. And so this line, the plus, it went and looked for this one or this one, found the first one. It's like, all right, I'm going to call this method. That's what it means for plus. And so it ran all this code, gave back a brand new counter that I can then go and use. How cool is that? So we can say what it means for the plus operator to work on our counters. Any questions about that? It's pretty powerful to be able to do that. All right, let's do another. Let's make another operator. Let's do plus plus. Let's have a counter plus plus operator. So instead of saying inc on counters, let's just be like C++. That'll be fun. But in all honesty, you can implement any operator that you want. Like, what does it mean to multiply two counters? What does it mean for one counter to be less than another counter? How do you give that counter to an output operator, like to cout, to something that can output with that operator? Oh man, that's very powerful. So you don't have to like get pieces out of it. It's really cool. So there's a bunch of different options. There's like a list of all the operators that you can overload, and it's pretty much all of them. So all these guys, arithmetic operators, plus what does it mean to divide counters? You can overload the assignment operator, the plus equals, a bunch of things that you haven't learned about yet. What does it mean for two counters to be equal to each other? It's so cool. There's a bunch more way down here too, I think. It just looks a little weird. You can overload all of these. Right? What does it mean to negate a counter? If you want to implement that, have the exclamation point mean something for your counter. You could implement that operator. It's amazing. All right. So let's make a plus plus operation on counters, and we'll have that be another method, I think. So instead of saying, which we have already, we have the inc method, right? We could say sum.inc, but we're cooler than that now. We know about overloading operators. Let's make a plus plus operator for sum. For a reason, it's going to be, I'm going to have it be the prefix plus plus rather than the suffix plus plus. It gets a little complicated to do the other one. It's a little silly, so I'm going to do it this way first. All right. But what this is going to do, if I have just planned to do this in the class, C++ will go looking for a method that looks like this: sum.operator plus plus with no arguments. Okay. The alternative would be an operator plus plus function that takes sum, but that's a little silly. So let's implement it this way. This is what it's going to be translated into if we make a method on counters, because sum is a counter called operator plus plus. That's what it means. That's what it's going to go and call when we run this. So let's go and make that. How fun. So let's see. Let's go up here. Let's declare that it exists. So it's called operator plus plus. That's what's going to get secretly called. It's going to be translated into that call. Takes no arguments, no parameters, and it's just void. It is going to mess with our counter, so it can't be const. Right? So operator plus plus will be called for us, and then let's go down here and implement it. So if somebody says plus plus on our counters, it will go and call this method called operator plus plus. And what do we want to do here? Well, we just want to add to our count, right? So you could technically call inc on yourself if you wanted to, or you could just say count plus plus, the same body as the inc method. Isn't that fun? So if you implement that, again, let's see if I can split screen it this way again. So there's the implementation, and here I am using it right here. This line will get translated into this call, which jumps up here, does exactly what you would expect, and the sum count has changed. So now we should see 78 at the end there. Beautiful. Any questions about that? It's powerful to be able to make your own operators and have them do exactly what you want them to do. That's glorious. So I think the last one that I want to show you, if we're happy, is to implement the less than operator. Let's implement the less than operator on counters, because that would allow us to sort them, right? So, you know that sort function, that secret one that I wanted you to use in your last lab? So if you put your stuff, like if you put a bunch of counters in like a vector, let's say, you can sort that vector as long as you tell C++ what it means for one counter to come before another. So here's a vector v a vector v of counters. I want to put sum, then c, then d. And so I think sum was 78 right now. Let's count as 78. C's count was, I think, 43, and then D's count was 34. Maybe I want to sort these on their counts, so that should go D, then C, then sum or something. I can do that. I can pass along the sort function is defined in the algorithm library. I can call sort on the vector v, v.begin, v.end, if you remember that. I can do this. I can use this as long as I tell C++ how to sort counters, because this is a brand new type. C++ has no clue what it means. Like, does C come before sum, or like sum come after C, or whatever, something like that. It needs to know the ordering. Like, what does it mean? Does C come before D, or does D come after C? D come before C, right? So, like, what is the ordering of each pair of those things? What does it mean for one counter to be less than the other? Okay. That is what we have to do. So sort, if you implement this, sort will call operator less than. We'll call the less than operator on two counters. All right? I hope that makes sense, because it's going to try and compare them. It's going to, like, somewhere inside of the sort function, I think you can imagine. It's like, if v at, like, I is less than v at j, let's keep them in that order. If they're greater, let's swap them. Something like that is going to happen inside of the sort implementation. And so it just needs to know, what does it mean for one to be less than the other, one to be greater than the other, right? And so we just have to use operator less than, and it'll figure out everything else from that. So let's implement what it means for one counter to come before another, all right? When is it true? So let's implement the operator less than method. Let's implement this one as a function, because when somebody says this, right? If somebody says, hey, is C less than D? This will be translated into either a call to C dot operator less than D, either it's a method or it's a function called operator less than on C and D. Let's do it this way for once. Let's implement it as a function defined outside of any class, right? Let's implement the operator less than function. Implement it as a function. So it's called operator less than. It takes two counters, the two things that you're trying to give to the less than operator. So counter A, counter B. We're not messing with them. We just want to use their values, so we can pass them along as constant references. Const counter reference A, const counter reference B. And if you're comparing things with a less than operator, is A less than B? That's what's being asked right now. You give back true or false, right? So the return value of an operator less than function of a less than operator is true or false. Is it less than? Is it not? Okay. And then let's compare our counters just based on counts. So let's return whatever A.count is compared with B.count. Something like that, right? That'll return true if A comes before B. Like, that's how we'll define A to come before B. Okay? Does that make sense? A's count being less than B's count. So that's the goal. That's how that should work. But this actually won't compile right now. Because, oh no, this is a function. This is not a method right now. Count is a private member variable, and this is just a normal function that's using our counters. So it's private. G++ was very helpful here. It's like, hey, you have a getter. You could use get count right here. That was great. But that's what we should be doing. If this is a function, we cannot access our member variables. They're private. Get count. Hey, is A's count less than B's count? And I'm getting them with the get count method call. And so a counter will come before another one. A counter we're considering counter A to be less than counter B if counter A's count is less than counter B's count. That's how we're defining it. Okay? And so once we give this to C++, it's like, all right, yeah, I understand. I know what it means to sort counters now. I can tell you when one comes before another, and so I can sort them all if you give me a giant vector of them. I understand. And so watch their counts be sorted. Let's iterate through V after we sort it for every counter, call it CTR in V. Let's output the count of that counter. Maybe we'll space separate them. This is it's a little bit of a complicated example, but it's a cool one, I think. So I can put a bunch of counters into a vector, and I can call sort on them, and it will be happy as long as I tell sort how to order counters. Here I am telling it. If you ever use the less than operator on counters, call this function and give back true or false. This is what it means for counter A, the first argument, to come before counter B. And so it'll sort these, and then it's going to go, I guess it went D, then C, then sum. Okay? Because putting them out in that order, that was not the order that I gave them in. But now they're sorted by their counts. Are there any questions about that? There's a lot going on there. There's the use, and here is the operator. So you can implement any operator you want. But less than is a great one because now you can sort things. Let's see here. Yeah. Any last questions about that or anything else? Because we made it. We made it to the end of our class's slides. Yay. Alright, so new topic next time, but we did it. You know how to write your own classes and get super fancy with const and initialize your lists and operators. Have a lot of fun with all that. Yeah, so I think that is everything that I want to do. It is just the lecture for the day. So the rest of the time is yours to work on stuff that is already out.